Okay, we're going to be getting into mirrors and lenses and reflections and images, and that's what we're going to be doing during this chapter. So for this section, you are going to need some type of ruler with a centimeter measurement on it, and we're going to be looking at concepts such as the object that's going to be in front of a mirror, the image that is produced, and also we're going to be looking at the characteristics of how far away from the mirror is this object and how tall is this object. Those are some of the main concepts that we're going to be looking at for this. Let's go and talk about what a plane mirror is. Now, a plane mirror is not like an airplane mirror. A plane mirror is, this is a terminology like in geometry. If you remember, this paper is a plane. It's a flat surface on which I can draw points and lines. So plane is this flat surface. So that's what a plane mirror means. A plane mirror means that you have a flat mirror. Well, what other types of mirrors do I have? You can actually have mirrors that curve inward, and you can have mirrors that curve outward. And we'll get to those. Those are called convex and also concave mirrors. But this is going to be a flat mirror, and because it's flat, it's going to be providing us with a regular reflection, as opposed to a diffuse reflection when you have a rough surface. So we have a flat surface, we're going to be getting regular reflections out of this. So if you could take your ruler and if you can draw a line going up and down, right down the middle length of your paper. This is going to be our mirror. What I'd like you to do is, if you can then measure 6 centimeters away from your mirror along this line that looks like this. This is where our object is going to be, and this is the distance that our object is away from the mirror. So this is going to be symbolized as lowercase d sub o, and this stands for the distance of the object. Distance of the object. Now, for simplicity's sake, if you can take your ruler and just draw upward, maybe 2 lines like this. So let's say this is a ball, or it could be a person, it could be a candle, it could be any object. Okay, and the object is drawn with an arrow going up to represent that this is the direction in which the object is standing. So this is symbolized as lowercase h sub o. This is now the height of my object. So I have my distance of the object, how far away from the mirror it is, and I have the height of the object, how tall it truly is. The object is symbolized as a capital letter O for the object. And this is going to be the source of light rays. It's the source of light rays. And I'd like to explain what I mean by that. I think I've referred to this before. Imagine that there's someone sitting in the middle of the room and the lights are on. Everyone else in the room probably can see that person because the rays of light are falling on that person in coming from different directions, and they will then reflect off of that person, and then they will finally meet into your eye. Therefore, everyone is able to see this person in the middle of the room because the light's coming off from all the different directions, and it's reflecting back to those people, and what you are going to be seeing is the light that's bouncing off of that person. So what we're going to be doing in this is we're going to be following 3 rays of light that are coming onto this object and then reflecting off of this object, then reflecting into the mirror. Okay, So if you can now take your ruler, and if you can measure, we'll just say 3 centimeters down from this. Okay, so imagine that our first ray of light is coming from this point right here, and it's hitting the mirror. Because this is a flat mirror, this is going to be providing a regular reflection, which means that the incoming angle of the light is also going to exit at the same angle. So if you can turn your pages, we're going to create a little normal here. Remember, your normal is the 90-degree angle at which the incident ray of light is coming in. So here's our angle of incidence, and we're going to have an equal angle for the angle of reflection. So what I'd also like you to do is this. I'd like you to extend a small, just very thinly dotted line going down your paper like that. We're going to need that to measure the distance. So here is our normal. Instead of measuring the angle with a protractor, we're going to be trying to do this with measurements. So the angle, this light ray comes into the mirror, it's going to reflect off at the same angle. Well, we're going to measure how far that this is. This is actually about 4.8 centimeters. So whatever distance that it is for you, mine's 4.8, but you can actually extend this down to being 4.8 as well. Why did I do that? Well, because the light ray is coming off of this point here, hitting the mirror. So therefore, when it reflects at that distance, we have to be the same distance away from here. These are sort of like equilateral triangles. Okay, so if this is the same angle, this is the same angle, this is the same length, that's the same length. We have this, if you remember, side angle side. We're not going to get into those geometry things, but this is showing that this is coming off at the same angle that it went in. We're going to do that again, and let's say that we're doing this, we did it at 3 centimeters from this line. Let's do it now at 5 centimeters from this line. Imagine your second ray of light is coming off of the object like this. Okay, it's hitting that point. Let's extend the normal. Here's the normal, providing the 90-degree angle right here. And let's measure from the top of the object to this point right here, which is the point that it's reflecting off of the mirror. For me, it is 6.8. So I want to then travel down, whatever it is for yours, you have to travel down the same distance. And it's going to be 6.8 right here. So that means I'm going to have my reflecting ray coming off like this. Okay, so I went down 3, I went down 5. Let's go down to 7, away from this point right here. And I'm going to draw my normal. Okay. And again, I'm drawing from the point of my object to this point on the mirror, and that light ray is then going to reflect off of that mirror. Let's go ahead and measure how far is this away from the top right here. And for now, this looks like it is going to be from here to here, it looks like it's about, it's about 8.8. So I need to come down about 8.8 here for my reflected ray to come out. So it should look something like this. And an interesting phenomena about a mirror is if you're standing 6 feet away from a mirror and you're looking into the mirror, where is your reflection? Your reflection actually is inside the mirror. In a flat, regular reflection, your reflection is going to be on the inside of the mirror. If you're 6 feet away from a mirror, your reflection is 6 feet inside the mirror. If you're 2 feet away, your reflection is 2 feet inside the mirror. Let's follow this, because in order to have to see some type of reflection, your light rays need to converge back in your eye. However, when will these 3 light rays converge? They're actually going to be spreading out and getting larger and larger and larger. These light rays over here will never converge. So the light rays never converge. So we need the convergence of those light rays in order to form an object, or in order to form an image. Since they're not going to occur, what we have to do is we have to trace backwards to see where they would be occurring. So what I'd like you to do is take your ruler, go to your first line, and in a dotted line, I'd like you to go now backward to this side of the paper. This is called a sight line. Solid lines indicate that these are the actual rays. Here's the incident ray, here's the reflected ray. This is actually the sight line that goes backward from the reflected ray. Do the same thing for this one. Like this. And do the same thing for this one. And you'll notice that all 3 of these converge and come together, probably right around there. So this would be where my image occurs. Now, realistically, in the real world, this would be the same height as this, and it would be the same distance. So it's going to be kind of fun to see how good did you draw this. This was 6 centimeters away. I got about 5.6 centimeters. This was originally 2 lines high. That comes close to being 2 lines high. So I'm pretty close to it looking like this over here. But now we have some other terminology to fill in, and here's the distance of the object. This is the distance of the image. So again, the image is going to be the same distance into the mirror as the object is the distance away from the mirror. And this is going to be the height of my image. Height of the image. So over here on this side, we have the capital I for the image. And in theory, it should be the same height as the object and the same distance away from that object. And right here, these are your source of the light rays. These right here, we should say the light rays, these are the reflected light rays. The reflected light rays never converge. So we draw these sight lines. And what we see here at this point right here, this is where the sight lines converge. So the sight lines in this case are converging into the mirror the same distance as the object is away from the mirror. So because our reflected light rays never came together, and it was actually our sight lines that did come together to form the image, this is called a virtual image. A virtual image is formed when sight lines, these sight lines, converge, come to a point behind the mirror. So we have sight lines converge behind the mirror. There are some cases which we will see in which these lines can converge, and when your reflected rays do converge, this is called a real image. So a real image are when your reflected light rays converge. And they do so not behind the mirror, but in front of the mirror. So as a quick summary, we're looking at plane mirrors which provide regular reflections. We have the object, which is a distance away from the mirror. We have the height of the object and the distance of the object. Light is coming off, bouncing off of this object, and those light rays are what's going into the mirror. And these reflected rays will never converge, but when we draw those sight lines back, the sight lines do converge on the other side of the mirror. That's going to be giving us the height of the image, the distance of the image, and this is going to be a virtual image because our sight lines converge rather than having a real image where your reflected rays converge. That's it for now.